a few people here who might not know me or have listened to some of my conversations on being a safe aviator. I really like the PPP program. You guys are doing really good, smart stuff and getting things done as well. That's excellent. If you haven't listened to what I have to say, so I started flying for a living in '88, and I did an undergraduate degree in the psychology of learning theories because I'd just become this flight instructor. And all of a sudden, I was fascinated with how we learn things, why we remember things, and why we engage in the correct behavior afterwards. And then I went on to do graduate work in human factors in aviation. So I'm not really into airplanes. I'm really into aviators. Um, as a military aviator, I was a member of an accident investigation unit. Our job, I was not a forensic investigator. Our job was to interview crew members who had worked or flown with the incident crew. The one thing I have learned, and then back up when I retired in 2014, I started this company, and we now have 30 people in the company. And uh, I started flying TBMs when I had about 20,000 hours, and the last 7,000 hours in the last 11 years have been sitting in the right seat of a TBM, not really flying them. I get to log it, but really what I bring to the table here isn't anything new, but it's a rather large sample set of my direct observations and then our employee instructors observations that we meet with every week. And I think right now for the professional TBM aviators that are out there working in TBMs every day, I, I probably have one of the largest sample sets, maybe like Walt Adair or Jim, John Elford would have a larger sample set because they just did it for more years than I currently have. So while we talk about this event of loss of control, I'm going to really focus on the common errors that I have seen. I fly with over 100 different TBM pilots every year for the last 11 years, and and I see the same things. So if we, and this is my little shtick, I like to say this because it's the way my brain works. I'm a pretty simple guy. If we knew we were navigating across a large area, and on this old-fashioned map we saw a sign or mark on the map that said "There be dragons," we wouldn't go there. We would know the route to circumnavigate that. So tonight we're going to talk about where the dragons are. They're easily observed in pilot behavior, not all of our behavior, thank goodness, but we're going to look at the most common mistakes that we see. By the way, we're crashing airplanes for the exact same reasons that we were a long time ago. We're not making new mistakes. So let's all just take a good deep dive into the honest reflection on where aviation has been because it's going in the same direction it has, and we're doing it at a lower rate, but we're not making new mistakes. So, what is loss of control? There we go. That's working. Um, Andy Craig talks about, and this is one of Andy's slides. I just snapped it off of the at the convention, but we can see that in the historical TBM fatal risk area, loss of control is the primary villain. Well, in order to lose control of the airplane, one of the ways that we can do it is to get too slow. When I came to the community, I was going through initial training and I asked what the low Q speed was because in my previous life experience, we had, a VA, a VO, and then a low Q, the slowest we would maneuver an airplane. We didn't have that in our world at that moment. So I just thought, okay, so we want a 30% margin above stall when we're slow, 1.3 VSO, and the FAA says thou shall not bank more than 30 degrees within, I think it's 1,500 feet of the ground. So if you take that 30-degree bank angle and give yourself a 30% margin above stall, that would be a defined minimum maneuvering speed. If you don't go slower than your defined minimum maneuvering speed, you won't pulled the airplane out of the flight envelope. In 1933, Wolfgang Langenschweizer wrote Stick and Rudder. I'm sure many of you have read it. And he says that most of the pilots will wreck their airplane, power on, flaps up, maneuvering around the airport. Well, guess what? Since 1933, nothing has changed. We're still wrecking the airplanes. Most of the time, power on, flaps up near the airport. Andy Craig talks about it in some of his presentations that one I just showed you a picture of. And he refers to it as the red zone. I'm sure many of you guys have heard that. Almost all of our loss of control events, excluding a couple of icing events, Minneapolis, Morristown, New Jersey, and an unknown event in Japan that was a loss of control event where the pilot pulled the airplane out of the sky, pulled it apart, and pulled it. Almost all the rest of them are within 3 nautical miles of the departure or destination airport and 1,000 feet of the ground. So right there would be the dragons, right? So we know if we're maneuvering near the airport, that's our greatest area of risk, especially if we're power on, flaps up. Life has this 80-20 rule, and almost 80% of those power on, flaps up events, loss of control events, happen on the go around. Steve Kleiman developed the TBM Performance app. I like to use this app. I teach this app all the time. Fantastic piece of information. So I went to Steve a while back and I asked him to include a defined minimum maneuvering speed in there. So I'm going to zoom in. We can see about the third line down, defined minimum maneuvering speed for the takeoff. For this particular airplane, I don't remember what this one, I think this was a 9 series airplane with quite a bit of gas in it and a couple of people. You can see that at a 30-degree bank angle and maintaining a 30% margin above stall, flaps takeoff is 111 knots. So if we maintain at least 111, then we know that we have or if you have an angle of attack indicator, they'll both read the same. For maneuvering flaps landing, your defined minimum maneuvering speed would be as slow as 89 knots. Why don't we have flaps up in there? Dyer has already given us that. That's our flap retraction speed, 115 knots. So defined minimum maneuvering speed, flaps up at a max gross weight airplane is 115. So we elected, and also for real estate in the app, not to include that. Dyer knew that. They knew what maneuvering speed was. They knew what a defined minimum maneuvering speed was. That's why they gave us 115 minimum flap retraction speed. Going on down to the next area that we see, or that 80% rule, I should say. Let's go down to the double line where it says GA, go around, climb rate, landing configuration. This is one of those maneuvering events where I frequently see pilots, especially when flying a coupled mist on their autopilot. So let's just put ourselves in the scenario we're flying a 930 on the autopilot. We reach decision height. I see the pilot hit the toga button, press the torque lever forward to 100%. The airplane pitches into the command bars, and they look down at the airspeed indicator and they see 95 knots. The common error we've seen many, many times is the pilot goes, oh, that's too slow. Disengage the autopilot, and at 220 feet, they push the nose over toward the concrete. In the debrief, I asked them, so what was your thought process? What did you observe? And why did you choose that course of action? The common response is, well, I've never seen 95 knots at 10 degrees nose up pitch. So I thought that must be an anomaly. So therefore I wanted to gain more airspeed, because normally I rotate and climb out at 115, 130. And so I was expecting to see 130. So one of the things that I recommend that we do is we use this TBM Performance app and we screenshot this page that we have here. That's our arrival page. And once we're coming off the top of descent, we're briefing our arrival and our approach, and we use these speeds to brief our minimum maneuvering speed. Say, for instance, even though we're IFR, we may be VMC, and the air traffic control may frequently issue us a visual approach. Join a 5-mile left base. Remember, most of our maneuvering, most of our events, unfortunate events, loss of control happen power on, flaps up. So if we're maneuvering power on, flaps up, and we haven't briefed a defined minimum maneuvering speed with this card, we're behind the 8-ball. The next thing is on the go around. If we haven't briefed our go around and landing configuration, by the way, at 100% torque, when you hit the toga button, you press the torque lever forward and pitch the airplane into the command bars at 95 knots. What are we flying? What angle of attack? We're flying at about 1.5 VSO. Those of us equipped with an angle of attack indicator, you'll see the airspeed tape and you'll see the little green donut sink below it. So we are nowhere close to a loss of control or leaving the flight envelope. Let's talk about the left turning tendency. So we have 4 left turning tendencies. 2 of them are not that, I'm going to say, not a big deal in the TBM. The gyroscopic precession, like when I'm flying my Super Cub and I stand the tail up on the takeoff, I have to stand the tail up and push on the right rudder at the same time, or the airplane makes a left turn. The next one is torque effect. And I hear a lot of people talk about torque rolls. I've intentionally played around with that, trying to get the airplane to torque roll. Sure, it has torque effect. All single engine propeller driven, or even turbine driven airplanes will have a torque effect. However, because of the counter rotating hot and cold sections of the PT6, in my experience, a torque effect in the TBM will roll the airplane about 20 degrees max. And it's rolling about its longitudinal axis. So therefore, the instinctive correct response is just right aileron. Not a big deal. Most people always get that right. However, the other 2, asymmetric propeller disc loading, or P factor, that descending right blade is getting a much bigger bite of air and therefore getting a lot more thrust than the ascending left blade, which is more like a hot knife through butter. It's not getting much of a bite. So as we pitch the airplane up, let's use the scenario that we were talking about earlier in the go-around, and we're adding the torque, that asymmetric propeller thrust is significantly greater and has a continuous curve increasing in its asymmetric thrust as we pitch the airplane up and as we accelerate, causing a yawing motion. The next big yawing motion that is significant to the TBM is the spiraling slipstream. So here we can see, I'm not sure how I'm going to work this without a cursor on this. We'll see how it works. All right, so here you can see how much accelerated slipstream we're getting over the top of the right wing in comparison to the left wing. You can also see the left-hand side of the fuselage, vertical stabilizer, and horizontal stabilizer are getting a lot more slipstream than the right side of the fuselage. Hey, anybody clean soot off their airplane? We already knew that. We also know in 2015, Dyer worked on decreasing the angle of attack on the left wing right in the slow flight regimes by adding a stall strake. The airplanes which are intentionally pulled out of the flight envelope with the stall strake behave a lot nicer than those who do not have the stall strake. I found that this video right here really helps me understand what the slipstream is looking like as it's going over that right wing. So essentially, the right wing is flying at I'll just say it's flying better than the left wing, all things given. Now, once you pitch here we go. Here's our little, can't be a flight instructor with a little metal airplane, huh? So once we increase that deck angle, that descending right blade on the prop, that's causing the yaw. The lower angle of attack on the right wing with that accelerated slipstream, causing that right wing to fly better. So we have the yaw, we have the pitch, and then at a certain point, the rudder is almost losing effectiveness. And we're going to look at some incidents and accidents where we've debriefed the pilot afterwards. And they said, I was stepping on the right rudder. I was giving it full right aileron, and the airplane continued to go over to the left. Well, that's because they didn't start pushing on the right rudder until they lost control of the airplane. Torque and rudder move together. You'll always maintain the positive control of the airplane with doing that together. Let's look at a pilot banking the airplane while maneuvering, power on, flaps up near the airport. Obviously, you can see we're at 9,500 feet. It's just an example here set forth for demonstration and discussion purposes. So let's take a look. We're at about 44 degrees of bank. Our deck angle is down half a degree, maybe. Our pitch limit indicator shows that if we pitch the nose half a degree above the horizon, we'll be at our maximum pitch allowable prior to the stall. Look at the two angle of attack indicators. One, the first green donut with the accelerometer built into it, it's fairly stable there where we're maneuvering, shows that our 1.3 VSO is at 128, 129 knots. And then, of course, the other icon in the just left of the 90 knots shows that the aircraft is very near stall. So why are we close to stall with a negative deck angle and 110 knots airspeed? Because of that lack of coordination. We can see that the airplane is skidding. Here, let's unbank the airplane. We're now still at 110 knots, but you notice our 1.3 VSO has gone from about 128 to 120 knots. We're still skidding the airplane. We are at a 0 degree deck angle. We're sinking at a 5 degree flight path angle. And our pitch limit indicator has gone from about a 1.5 degree separation to a 5 degree separation. So that Garmin air data computer is a really smart device. It knows if we're in trim, like this aircraft is, where the airplane is not skidding. And you notice that even though we're back over at 44 degrees and we pitched the nose up 6 degrees, our 1.3 VSO is still pretty darn high, isn't it? We were trying to maintain 110 knots throughout this demonstration. We're at 112, sorry for that. But that air data computer that Garmin has in the G1600 TXI and G3000, yeah, it does a very good job.
Hey, William, this is Van. We have a question from Dirk. I'll read it to you right now. He's asking, will forces on a gyro result in movement of the gyro offset by 90 degrees?
So gyroscopic precession is when a force is felt applied to a gyroscope, it's felt 90 degrees ahead of the rotation and 90 degrees ahead of the plane of rotation. So, we all know that, I mentioned that example earlier. Say, for instance, I'm taking off in the little Super Cub. I give it all the power. I accelerate the prop, and now I apply pressure to the top of that propeller by standing the tail up. So that force applied to the gyroscope is felt 90 degrees ahead of the rotation and 90 degrees ahead of the plane of rotation. So it causes a yawing moment. I hope I answered that well enough for you, Dirk. Although I imagine you probably already knew that, but I didn't mention it earlier. So thanks for filling it in there for me. I appreciate that. So, okay, so we've talked. We all know everything I've already said, right? None of that is new. one of the frequently asked questions I like to discuss with other aviators is what's a slip and what's a skid? Van, we had a good discussion on this just a few days ago, didn't we? So, uh, a slip, is the slip dangerous? Well, they're both uncoordinated flight. We both know that. And is the skid dangerous? Well, our air data computer here says that a skid might be hazardous. So let's look at what a slip is and what a skid is. A slip, a student pilot has to know and demonstrate this for their check ride. So here we go. Here's our little airplane. I'll get my ugly fat face out of the way here. And here's our slip. You're the relative wind, right? We step on the right rudder and we give it the left aileron, and the airplane slips toward the runway. What I want you to do while we're looking at this little airplane here, I want you to think about how the wings are moving in relation to one another. In comparison to what we have on this G1000 primary flight display, that's a skid. So, in order to describe a skid, let's look at what we normal and abnormal, because one thing that I have clearly identified is that abnormals lead to errors. Well, no kidding, right? How many times have something else been going on in the cockpit or your head or just in life, which has led to a mistake? So let's start with normal. What does normal look like? Let's put ourselves in the position ATC has asked us to make a 2 mile left base, land long, whatever. 3 mile left base. We'll make it even a little bit more realistic. So we're about 25% torque. We're at about 750 foot. I'm sorry, we're about 1,000 foot AGL on this 3 mile left base. I was thinking 2 mile left base is 750 foot. And our flaps are in the landing position. Our gear is down, and we're rolling. Here we are rolling out base to final. How do we know how much aileron? How do we know how much left rudder to apply? Oh, it's normal. We've done it many times. We're backing the car into the stall at the grocery store. We don't get out the measuring tape. We just eyeball it because we've done it. We can reproduce it. It's normal behavior. Here's something I've observed is when there is an abnormal, let's say the abnormal today is flaps up. Remember Wolfgang Langeschweiser's note in 1933, power on flaps up near the airport? So we're flying with our flaps up. Why? Well, maybe we had a flaps asymmetry. Maybe the circuit breaker popped out. Maybe one of the micro switches in that Rube Goldberg device underneath the throttle quadrant has stuck. Maybe we just forgot. Maybe we just want to go fast and we're thinking, I'll get those in a minute, and that minute hasn't come yet. Various reasons why we might be maneuvering near the airport with the flaps up. So what's different? Well, first of all, when we had our flaps in landing position, our deck angle was probably something like -5, right? Sound right? Base to final. Power on flaps up, base to final. What's our deck angle? Probably a +2, 2.5. That's a 7-degree difference. So what's our power setting going to be? Earlier it was say 20, 25, but it's going to be significantly more now, depending on your density, altitude, and the weight of the aircraft. So as we increase the speed, the other thing is, why do we have to have more power? Because those flaps, those 34 degrees of deflection, gives us an incredible amount of lift. The common error is we think, I'm going to need less power because I have less drag. Not the case in the TBM. With the flaps retracted, you're going to need more power to supplement the lost lift. So here we are. The difference is we have a positive deck angle, we have more power, we have more asymmetric propeller disc loading with that descending blade, we have more slipstream, we have more spiraling slipstream causing an additional yawing factor, and now we're going faster through the air, so we have a greater ground track. oh wait, my Mark 1 calibrated eyeballs that can turn onto the final approach with flaps landing is now no longer in calibration. So what are we going to do? Right? We're going to overshoot. Oh no, no worry. All I do is have to bank steeper and pull on the elevator, and I'll get right back into line. As we're doing that, look at the picture here. Where does the ball go? The ball goes out to the right. But my brain pushes on the left rudder every time I make a steep left turn. So what did I just do? As I'm going around the corner, power on, flaps up. This is a skid. Remember, look at the relative wingtip movements. They're moving together. But a skid is which wing is outperforming another wing. With the slipstream, the asymmetric propeller thrust, the pilot's stepping on the wrong pedal because that's a normal behavior in an abnormal situation, actually slows that wing down even more. And then to add insult to injury, as the airplane starts to go to the left, they add right aileron. That left aileron is deflected downward. The immediate byproduct of lift is induced drag, and the right wing outperforms the left wing every single time in that scenario, and the airplane, at the very least, becomes 90-degree knife edge. And 90-degree knife edge in a TBM requires about 5,000 feet of recovery. If you've practiced it recently, it doesn't require as much. Base to final of the 3-mile final in this scenario that I built, probably not going to work out well for you. So the other, hey, now might be a good time to pause, talk a little bit about what we've covered so far, if anybody has any immediate questions.
There's no other questions so far that I can see. If anybody's typing any questions in, I can't see them. Dirk, do you have any questions?
Yeah, well, comments on this, is well, thanks. This is all good. Part what our brains are thinking about, and I don't know whether this is the right time to mention this. How can we use, me and my team TBM monitoring, and add some extra criteria to to identify precursors. You mentioned DMM a number of times, and that's DMMS a number of times. So, for example, would it be appropriate to possibly add some criterion where we can programmatically check whether an aircraft once in a while goes below that number and just highlight that as a possible issue? So anyhow,
oh, that's a big issue. Yeah.
Part of the thinking here, and where your observations are helpful, is to possibly translate this into criteria to be added to the flight data monitoring to alert us that we're doing, unconsciously unsafe things, and provide feedback what actually happens. So I don't know whether this is the right time to bring that up.
Yeah, a couple of things that immediately come to my mind is, number one is anytime you're below a 30% margin above stall. Yeah, those aircraft, I would imagine quite a few of the guys on the call tonight have an angle of attack indicator. Anytime you're slower than 1.3, regardless of your bank angle, unless you're right over the runway, that's not what we're talking about. That's not where we lose control of the airplane. Then, yeah, so how do you, not me, because that's not my forte, how do you incorporate monitoring that? Don't exactly know what the program looks like, but that would be one area that you definitely want to monitor. The other area is that, are we skidding the airplane? I will have this even more animated, more in-depth discussion with the pilot, and then we'll go out and we know exactly where the dragons will be, and then we'll have a training scenario where the flaps have failed, and I will say if we do, I probably, everybody does probably 3 or 4 no flap landings during a recurrent, and during that time, at least once, I'll push on the right rudder during the left turn. In the aerobatic world, we call it top rudder. It's never right rudder, left rudder, it's top rudder, bottom rudder. It's a little easier for the brain to process that. So even though we know the airplane is going to be skidding unless we put in the correct inputs, and we just talked about it, when we go out and conduct the exercise, it's still common for us to make that error. So therefore, that would be the second point I would look for is, are we skidding the airplane? And I'm not sure how that would translate into the data. And there was a third one that was in my mind a moment ago. Oh yeah, the third one is, I personally, in the airlines and the military, we have to be fully configured when we come off the perch. The perch is defined as our last continuous descent to the runway. I personally prefer and I suggest the style when you come off the traffic pattern altitude, the glide slope intercept, or the MDA, you're fully configured. What does that do? Well, it gives you a bigger margin. It just decreased your stall speed significantly. I know many people have given me some pushback and they go, nope, I don't like to, I'll put the gear down at the final approach fix, but I want to fly as fast as I can until I get down there and I maneuver around the airport. And then I'll put the flaps landing on final. I think that is the exact behavior which leads to skidding the airplane and then the subsequential overcorrection. And then just one other point I was going to make on that, and I didn't. So while we're talking about it here, so we end up skidding the airplane, right? The right wing is moving at a better rate than the left wing. Remember, in the reverse region of command, anything slower than VY pitches for airspeed, power is for altitude. We all know that, but rudder is for rate. So what we have to do, we should not make that left aileron input, right? Because that even skids the airplane or slows that left wing down momentarily even more. And if you're right on the ragged edge, the right wing outperforms the left wing, right? So what we have to do in this scenario is put the airplane from a skid, right rudder, and accelerate that left wing. So now we go from a skid to a slip. And once we're slipping the airplane, then and only then should we lift the left wing with the aileron. So we're skidding the airplane around the corner. We don't lift the left wing with the aileron first. We accelerate the left wing with the right rudder, putting the airplane from a skid to a slip, and then lift the left wing from the slip back to level flight. I'm not sure how we could identify that in the data, Dirk, but not only do we need to train it, recognize it, but then if you can identify when the skid is occurring and the pilot uses the ailerons instead of using the rudder, that would be the third area.
Yeah,
I guess that's the fourth area.
The rest is detailed, but identifying the scenarios I think is very helpful. So thank you.
Yeah. So let's talk about so we had the proverbial base to final. Let's talk about the go-arounds. So go-arounds are low frequency, high intensity events. Training and familiarity, because they don't happen all the time, we end up becoming we have a lack of currency in go-arounds. And then we're not prepared to respond effectively or immediately. The second is cognitive loading. These high intensity situations demand really specific attention and critical decision making, therefore increasing cognitive loading and increasing the potentiality of errors. And the last is time pressure. This is because we've received, and I was an ab initio instructor back in the 1980s. I used to tell people, get your gear up, get your flaps up, got to get that drag out. That's just wrong. This low altitude, low airspeed, leads to a sense of urgency that we have to have fast hands in the cockpit. Van can tell you that one of the techniques I like to use, a teaching style I like to use, is toga, torque, and trim. Obviously, the right rudder is applied. That kind of goes without saying, right? Torque and rudder move together. And then pitch into and then do nothing. Don't retract the flaps. Leave them at landing. Don't retract the landing gear. Leave them extended. Accelerate. Retrim the airplane. Wings level. Climb up to 500 feet. Somebody who's got really fast hands will pause and climb to 1,000 feet, fully configured for landing. Why? Because we want to slow down. There's no reason for us to quickly retract those flaps. We will look at some accidents, maybe based upon time. I could talk about this for a very long time, where the pilots retracted the flaps immediately. Van could tell you that one of the things that we looked at last Friday was, okay, so this time let's add all the torque and let's quickly retract the flaps. What happens as soon as you retract the flaps? Well, we can see that we're getting very close to 1.3 VSO, where earlier we were 1.5, 1.6 even. As we were climbing out with flaps in the landing position, we retract the flaps to takeoff, goes right up to 1.3 VSO, and we get a min speed alert. Is it safe? Yes, we're still safe. But the point is, we were flying with a greater margin above stall with the flaps. We were climbing at a greater margin above stall with the flaps in the landing position. We are not in a big hurry to retract the flaps.
Yeah, during the training I just completed with William, I didn't think I did gear and flaps, gear, yaw damper, flaps in a hurry. But after flying with William, I saw that I was, and he'd say, wait, and everything was fine. We had great climb. We got away from the ground, and then we reacted, and it was a big takeaway for me.
Yeah. So I like to break things down and put, words have meanings, despite what modern culture has decided for us. I like to break it down into go around into three separate buckets. The first is a missed approach on an instrument approach procedure. We're probably 200 feet above the ground or higher. We have plenty of airspeed. We probably have a negative deck angle already. And we have a written plan of action that we have briefed. The difficulty is it's usually under instrument meteorological conditions. The next is a regular go around, low altitude, low energy, low airspeed. The runway's right in front of us. We think we're going to land the airplane, and then air traffic control comes on and says TBM-123, go around. And then the last is a balked landing. So we've flown the aircraft onto the runway, and we've touched one or three of the tires. Think Southwest up at Midway Airport, right? That was a balked landing. He flew that airplane, touched the left main, just squeaked it on, and then flew again. I have had some balked landings from either just crappy piloting, where I bounced the airplane off the ground and decided I didn't want to try to do it again. I've touched down, and then just after I've touched down, I live in a windy place a big chunk out of the year, up in the Northern Rockies, and wind shear is a daily event, especially in the afternoon, and the airplane we start to lose directional control. It's safer to go flying again than it is to take it down into the ditch. One time I touched down at Westchester County after just completing an ILS approach to just above minimum, say 350 feet or something like that, and a Global Express taxied out in front of me. And it was safer to take the airplane flying again. Nose gear hadn't even touched the ground yet. Safer to take the airplane flying again because I was not going to get stopped before it hit the global. 700 Alpha Quebec. You guys may know this. I think it was Lansing, Michigan in October of 19. The NTSB coined a phrase called the torque-induced stall. Well, I disagree with the concept altogether of a torque-induced stall, because torque, what is torque effect, right? Torque rolls about 20 degrees of bank angle, then reaches equilibrium. And what's the intuitive smooth corrective action for that? Just use your ailerons, right? It rolls about the longitudinal axis. That's not stalling the airplane, is it? No, we may lose a little bit of directional control, but that's easily regained. The stall, as we all know, is exceeding the critical angle of attack. I think that we are misusing the discussion in our community about torque rolls. No, it's the pilot pulls on the elevator, and then those left turning tendencies kick in, and then the right wing outflies the left wing, and now they've lost control of the airplane. Remember, those left turning tendencies are controlled with the rudder because the rudder is for rate. The wingtip rates need to move together. Even if we're uncoordinated in a slip, that's okay. Slips are not dangerous. The skids are. 700 Alpha Quebec. Here it is. He flew a less than stable approach with 6 people in the airplane, over gross weight after the datum line. He had 74 hours in the airplane. This was his first full missed. Didn't receive any good training at either SimCom or organization like ours. He got his initial in a Redbird simulator, which might be different than a TBM. And on the mist, he applied some power. We can see his lack of directional control on the yellow indicated path here. And what did this pilot do? Well, we can go back to the picture and we can see that, and then the NTSB, his gear was up and his flaps were retracted. So he gave it some power. The airplane yawed to the left. And at the crash site, the power lever was at idle and the flaps were up and the gear was in the retraction, in the process of retracting. Again, the common errors we see on go-arounds, I shouldn't start the sentence with again, that's poor. I like to say the common errors we see with go-arounds, I see this often, is the pilot applies partial power. What is it? FIL 2019 T9 says, correct me if I'm wrong in that flight information letter, but it says how much percent of the torque? 100%. Just like on takeoff, we don't have a reduced power takeoff. We do not have a reduced power go around. However, we frequently see in training two things. Number one, the pilot gives partial power and then quickly retracts the flaps. 700 Alpha Quebec, the one we just looked at, is a perfect, clear example of that. Or what we see is the pilot gives partial power and then pauses. And in the training environment, if you guys have flown with me, if you've made that error, even for just a second, I'll say, all the power, all the power, all the power, just to kind of a mental cue. Let's look at this next common error. This pilot made this latter common error by, during a go-around, applied partial power, gave it full right aileron, gave it some right rudder, and lifted the nose a little bit too high. You'll notice the angle of attack indicator on the airspeed tape. It shows that we're well below 1.3 VSO. And then the pilot made an additional error and reduce the torque. We'll look at it at full speed here real quick. Gear is down, flaps are landing. There are no mechanical abnormalities in the airplane. And then the guy in the right seat shouts, "Look out, there's deer on the runway, go around." And we have a little bit of a roll and a yaw and an impact. Okay, let's look at that in quarter speed. Happened pretty quick, didn't it? This time, let's keep our eye on the torque. So we are very slow. We are near a stall. An attempted go around is initiated. 44% torque. If the pilot would have applied 100% torque and lowered the nose, the airplane would have flown right out of there. And then the pilot reduced the torque. This is another common error that we see. Again, that's not the most common error. The most common error is partial power flap retraction. 700 Alpha Quebec, good example. And then the next common error is the pilot applies power and then reduces power. During the debrief, the aviators I share the cockpit with were not aware that they were doing that. So that would be something else, Dirk, that a good algorithm could look for. There's where the airplane ended up, unfortunately. Both pilot and the instructor, who this was his first flight in the TBM and his first go around. I spent 6 hours in discussion with him on the aerodynamic causes of this. The FAA brought me in and asked me a whole lot of questions on TBM behavior. I asked them, so why are you should be talking to Phil down at Pompano? And they said, well, Phil knows the airplane, but why do the pilots do this? The answer is, I guess we're still making the same mistake. So, Dirk, another point that you could be looking at is the rate in which the pilot goes from their lowest point of torque prior to the go around to 100% torque. Is there a pause, or even worse, is there a torque reduction during that? The stabilized approach is great, and probably even more important is the stabilized go around, if we could coin that phrase or use that phrase.
William, we've got on our
Yeah.
schedule, but we've got about 15 minutes left.
Let's stop and take
no,
questions now.
I know you've got lots to cover and can continue
Yeah.
to cover. Dirk has a few points that he wants to make about PPP after we're done here, that you're welcome to stay in. That he needs about 10 or 15 minutes to do that. So does anybody have any questions? You can unmute yourself and you can verbally ask it, or you can type it and I'll read it to Will. Otherwise you can.
This is Brian Dunser, and hi, Will. Thanks for presenting tonight. I've got a question. If we're properly using the yaw damper, the airplane is always going to be coordinated with that on. Is that a correct statement?
That's correct. Yeah, the yaw damper is a safety device, and one of the things that I recommend, now that Daewoo has even added it into their G3000 update on the 960, the yaw damper comes on at 200 and goes off at 200. I think that standardizing, remember, consistency equals accuracy and safety. It's my recommendation. The gear comes up, yaw damper comes off, and the yaw damper is disengaged in two locations. Number one, VMC at 500, use the yaw damper all the way to 500, so you're descending, decelerating, and that yaw damper will trim the rudder where it needs to be for landing and needs to be for a go around. So, for instance, if you disengage the yaw damper on your GFC 700 autopilot with a really sharp descent and a high airspeed, that rudder is going to be trimmed left of center. So then in the go around, and in the Michigan crash with Randy and Allison, that rudder was trimmed left of center. They had disengaged the yaw damp at a steep deck angle, high airspeed, at a poor time to do so, and then failed to do the after landing of the before takeoff checklist. And witnesses said the airplane, it was also trimmed all the way nose up for takeoff, which didn't help, and it had ice on the wings. It's 3 strikes, they're out, unfortunately, very unfortunately. Randy and Allison were friends of ours, and Allison, been flying for a living for 20 years. They certainly knew better. Was my wife's seaplane mentor. So this one of those, another one where it's hit very close to home. But witnesses said the airplane over rotated and immediately yawed. So disengage the yaw damper at 500 feet VMC or at decision height when you have the runway, when you are flying a coupled approach.
So William, small correction, I think. The yaw in the 960 that with the service bulletin, the yaw damper is engaged at 200 and disengages at 150 GPS height. So,
well, thank you.
Hi, this is Michael Rose. I have a question. I don't have my video on here. I'll put it on real fast. The accident that just happened in Minnesota, if I've sort of read through it, right, it seems like he was very slow and fully configured coming over the top to start onto the glide path. And so he's in icing probably conditions, fully configured, full flaps, and slow. Because that situation, obviously, we all know you have to go faster in icing. There's recommendations by Daher, but that would be a situation where maybe you wouldn't be fully configured and go faster until you're, down on a downslope and able to unload the wings and not just be slow with a high deck angle. I'm just wondering if that, some mindset of just always being configured when you come over the top contributed to this.
Two things. The major contributor is we're looking at the wetware here, not at the hardware. TBM is perfectly safe to fly in ice as long as you follow the correct procedure set forth by the manufacturer and FIL 2017-T4 minimum approach and landing speeds for that airplane, fully configured, flaps landing 95 knots, flaps takeoff 115, and flaps up 135 knots. The airplane and the pilot would have been just fine. However, what I see the common error is we have an abnormal event. I have an airplane covered in ice and I engage in a normal behavior. I frequently will have an icing lesson, and then we'll go out and we'll fly that profile with simulated contaminated wings. And the pilot says in their mind, I'm going to take a little liberty here. Oh, let's see, fully configured 95 knots, 95 knots. I need to fly 95 knots. And then they're flying 95 knots and they level off for a second. And because they have airframe icing, the airplane quickly decelerates, as we saw in their ADS-B data, quickly decelerates to 80 knots. And then at 80 knots, they exceed the critical angle of attack, which can be as low as NASA's Glenn Research Center says, with airframe icing, your critical angle of attack can go from 15 to 5.5. And I know that there's been some demonstrations where TBMs have left the flight envelope with light ice with 7 degrees angle of attack. So 7-degree angle of attack can happen quick, fast, and in a hurry, especially those last few knots. And then we saw that airplane was making maneuvers like this while it was power on, and you could tell from the angle the airplane engine was working, because airplanes fully stalled they do this, right? That airplane was doing this. So what happened is he lost control of that left wing. The right wing outflew the left wing, and then he added the power, and it was unrecoverable. So in FIL 2017 T4, Dyer gives us a link to the NASA's Research Test Center, Glenn's Research Test Center, and they did all the work. And in that video, they say if your manufacturer provides you a partially extended flap setting, take off 10 degrees, and an associated speed, either 110 or 115, check your POH for that, then that's what they recommend. Remember, that's not our approach speed. That's our minimum landing speed. That's not the recommended speed we fly the airplane. There's no margin. If I said your clean stall speed today is 77 knots and I want you to fly the approach at 78, would you look at me funny? Right. So that 95, 115, 135, that's over the runway where it's safe to stall and fall. The rest of the time, we should be flying as fast as we safely and practically can.
Thank you.
Remember, the faster we fly, the warmer the total air temperature is. 90-some-odd% of all the PIREPs made for airframe icing are between -5 and -15. And at 200 knots, total air temperature is 8 to 12 degrees warmer than outside air temperature. So if we're flying, and you could fly up to the last 5 miles at 200 knots. So he was, I believe, I've looked at all the weather there. I believe that he probably, I don't know for a fact, that he was probably no longer accreting ice. So if he'd been doing, based upon the lapse rate, if he'd have been doing 200 knots up to that glide slope intercept with his flaps up and his gear up, not having any drag, he would have had he would have been successfully with his total air temperature above airframe icing, and he wouldn't have had any airframe ice, at least on the leading edge. I don't know if it was any on the rollback. That's something for the investigators.
Let's get 1 or 2 more questions, and then at 7 o'clock, we'll get Dirk to give his PPP update. I think this has been really helpful. Thank you very much, William, so far. Any other questions?
I'll just point folks to Steve Kleinman's DMMS discussion in the chat. DMMS is a made-up term, and different organizations can come up with different definitions, but in the TBM Performance app, Steve uses the formula that I'm used to, which is basically the stall speed at a 60-degree bank, so a 2G turn, and you should never even be close to that in the pattern, not even 45. You know, as William said, 30 degrees is the max bank. And so the DMMS at the stall speed at 60 degrees gives you that 1.414 margin. So there's no other factors. That is the actual stall speed at a 60-degree bank. And so if you fly at that speed that's in the performance app, that gives you an enormous amount of margin, a safe amount of margin. So
yeah, I think Steve's on the call. At least he's showing. If you want to add anything to that, Steve Kleiman.
Hi, yeah, can you hear me?
We sure do.
Okay, good. Yeah, it's the stall speed at 60-degree bank. That's what's computed in the app. It gives you 30 degrees of margin, not 30%, over 30 degrees of bank. And that gives you as John said, the usual one square root of 2 factor in stall speed. So I just want to clarify that.
Yeah, I think probably everybody on the call is using your app. Everybody finds it incredibly useful. Thanks for all the effort, Steve, and everybody else who participated. So we're coming to the end, and I think, and William, you don't need to leave, so we can thank you after. If you need to leave now, you can, and we'll thank you now. Okay, stick around.
Listen.
Yeah, Dirk, if you'd like to, so I'll take over the screen. I've got Dirk's deck here, and he can discuss and talk about a quick update with PPP, explain what it is and what we're trying to accomplish. So I will do that now.
Okay, Van, thank you so much. Just to be really quick, David, do you want to just say a few words since we just had a little side discussion? David Pettit is head of safety at Daher and overlooks together with Marie the Me My TBM and the FDM program. So I just want to invite you to say a few words on what we just discussed, and then we'll have some follow-up to possibly add some criteria, maybe needs to use the TBM report as a guinea pig, as we have done before, to start to have some metrics that can be used as precursors to loss of control accidents, as well as you just suggested. Clearly, we need to look at some data to be effective and do as little as possible. But I thought maybe, David, you'd just say a few words. I apologize for putting you slightly on the spot. David Pettit, you're with us. Are you okay? I know he's on, but maybe he's distracted for a second.
You hear me now?
Yes.
Yes. Hi, everyone. So thanks very much for the presentation. It was great, great ideas, and I appreciate that I was invited to that event. So yeah, there's a good thing we need to look into probably is the idea of increasing the number of parameters that could be monitored with the Me and My TBM, as it focuses on the approach, but the final approach, which is one part of the flight, but there's so many other parameters that we might think of looking into, like the DMMS and the other parameters, as William mentioned, an aircraft skidding or sleeping, stuff like that. So I'm open to kind of discussion in the future. And I wasn't really prepared to jump in that meeting, but thanks for the opportunity you gave to me. Thanks, Dirk. Thanks, everyone.
Okay, excellent. Thank you so much. On that note, thanks, David. On that note, by the way, TBM-PPP is collaborative, but let me just go through quickly some things. Originally, it was created in March of 24 last year. It's basically just now, basically exactly a year old. And it was created on the base of the, the safety analysis that we did some time ago, which basically showed that the vast majority, or this is about landing accidents, that compliance with the simple 500-foot airspeed being below 50% is associated with 90% of the accidents. So there's no, and so then the idea was, well, why don't you form a group that has only pilots in it above 80%, demonstrate to the insurance companies that this group has a materially lower accident rate, statistically significant, and then see whether we can get better access. That was really the whole point. And so we've just moved to the next slide, Van. Again, so you can see this is what's been distributed. The goal is 0 accidents over 3 years, and the objective is better access to insurance. In that context, things have to be measurable. Safety is a personal commitment. Adding a safety buddy as a sounding board so we can discuss things privately. And so now the next slide will show kind of what's been happening over the last year. So yes, it was March 2024. It was launched at the AVIC seminar. The group has created and adopted, an SOP and an SMS under the leadership of Stu Phillips. Really, the group has 52 members to date, and was possibly the most interesting number, has 63,000 accident-free flight hours by this group represented. And by the way, accidents are usually measured in the context of accidents per 100,000 hours. So this is getting to a number that is at least not irrelevant. Statisticians wouldn't say this is relevant quite yet, but it's pretty significant. FYI, the mean my TBM scores for the group, and every member of this group, as everybody knows, has to use mean my TBM. The average score of the group is 93, with a minimum 86 and a maximum 100. And then last not least, there is there's a more and has 550 posts. So that's pretty good progress. What's on the agenda to do next? Grow the membership, and then following with that, reaching out to the underwriters, which is part of the original goal. The workload has been expanding as the group has been growing, and with that, considering inviting members who are interested to expand the moderator group, which does a little bit more of the thinking. Van, you're of course high of the list, since Van took the initiative to actually make this happen. And then last not least, there's an idea of preparing an AOPA magazine article, just because that tends to kind of, focus the activities. And any comments and questions? One of the things that JJ has pointed out, that, some members are asking that why is TBM-PPP not part of TBM-OPA? And, that's under discussion. One of the basic things is really very simple, that TBM-OPA is trying, for the obvious reasons, to have as many members as possible out of the community and have, a market share of, 50+%. And this program is, somewhat restrictive. And, not everybody is interested or willing in signing up to this. And in that context, the objectives are slightly different. I mean, for example, CJP made a decision a long time ago, like, was it 5 years ago or somewhere there about, John, right? That they moved from an organization that was going after market share from an organization that was focused on a quality program, invested a lot of time in simulator things. But, those two goals, these objectives are just, inherently differently. And we're going to be discussing, how to deal with this to have a coherent program. One of the issues is, for example, it's not really a good idea that there are multiple SOPs for the flying of the TBM. But anyhow, interested, anybody has any comments on that topic as well?
Thank you, Dirk. Any questions for Dirk? And if there are none, then we'll ask William if he still has a few minutes to answer any other questions. And if there are none, then we'll thank everybody and move on.
This is Michael Rose. I have one kind of random question. I just got my TBM, and I'm learning and doing a lot of training. And sometimes when I do training, we do all kinds of weird landings, no flaps, half flaps, and my scores get messed up because it says I didn't have flaps in at 500 feet and whatever. And I don't think you guys are using my score yet because I'm not sure I've totally coordinated with the group on that. But how do we eliminate those so they don't get counted if we're doing them on purpose for training purposes?
So on me and my TBM app, there's actually a setting where you can change the category of the flight. And you can identify it as training, and then it's not scored.
Gotcha. And similarly, I've gone in for service and they take it up for a test flight and I look at it and it says that there's like a 60% score. And I'm like, oh God, that's going to hurt my, I guess you could do the same thing and make it a maintenance flight or something like that.
And make it, exactly. Yep.
Well, on that topic of the maintenance flights, that's a very, very interesting observation. I'm keenly aware that, a number of members have pointed that out, that sometimes TBMs flown by pilots of the distributors result in scores that are not optimal, and so AVEX has made it very clear to their team that when AVEX pilots fly, the scores need to be perfect. That doesn't seem to be necessarily the case around the universe, but an interesting question to maybe David we can discuss too. I don't know what Daher's stance on that one is, but it keeps on coming up. Sometimes there may be good reasons why personnel from the service center shouldn't adhere to the POH themselves, but anyhow, it's something where some clarity I think would be helpful and would avoid some of the snickering that's in the background on this topic.
Yeah, Danielle Booth, I think, is on the call with AVEX. Is there anything you want to add to that, Danielle?
With respect to the distributor pilots specifically operating the aircraft?
Yes.
Yeah, I think that they have put in the app a place where you can designate that a pilot was flying the plane so it doesn't affect your scores. But obviously, our pilots are pretty skilled professionals. And now that they have got some feedback from some customers, they're a little bit more mindful of the approach report scoring and stuff like that. But for the most part, if you're coming into, just like you guys, if you're coming into a short field or a different outside the normal approach or something like that, they sometimes see some deviations. But I think they do have a designation in the app now that you can say that it was a different pilot flying your aircraft. So you can go ahead and splice that off individually. And we're happy to field any comments on our pilots in particular. I think that, our guys are pretty skilled and they're not putting your plane at risk in any situation. Sometimes sometimes the guys, just like Will, that fly the plane very, very well, they wear it, and it's a little bit different situation than other people.
Got it. Thank you. Any questions for either William or Dirk or anybody else?
Yeah, Dirk, this is JJ. One question I had is that when that information from me and my TBM gets transferred to you, is it already filtered by these choices of categories, or do you get the whole database and without the option of dropping out like training flights and so on?
Yeah, JJ, very, very good question. As of this moment, Daher provides, for owners who authorize this, the raw data, and TBM report is striving to basically be a replica, short of the fact that it's also an accounting tool just to measure how many hours are being flown within the group. So as of this second, when you flag a flight as a training flight and meet my TBM report doesn't know this. Now, we can possibly change this going forward. I can actually, as of this second, this is manually, so I can pretty trivially flag a flight as to be removed from the scoring. So for the time being, members of PPP feel free to reach out and have me do that. And if we have to automate that, we can make that happen.
Yeah, I think that's important because folks that maybe 85%, and they also do a lot of training and do unusual approaches and so on. that may drop them down below the 80% if you keep all those scores.
That's actually fascinating. I mean, I didn't show the histogram of the distribution of the scores within PPP, but it's actually really quite high. I mean, and funnily enough, it's a group of people who are, you know, striving to be on the upper end, and the vast majority are really above 90. So there's some room there as well. But anyhow, the bottom line is it's trivial for me to actually do this manually right now. I'm happy to do that.
Yeah, well, that's good to know.
Hey, Dirk, this is Brian. I'd have one suggestion. I think it would be advantageous to put together, a small group of people who could really examine this situation of being a member of TBM-OPA, being a member of PPP. It saddens me when we hear of an accident and the pilot, had nothing to do with either one of the organizations. I always think that being a member of TBM-OPA at least can provide perspective on different safety issues. And if an owner isn't involved at all, we've kind of lost them, and we've got half the fleet that may not be thinking about any of these things we're thinking about today. So, I would ultimately like to see, and my personal opinion is, a combination and how we can bring more people into PPP by using the membership of TBM-OPA.
Ryan, this is Stu Phillips. Sadly, and the FAA has a wonderful term for this, a very large portion of general aviation pilots the FAA describes as the unreachables. No, very serious. These are the people who never attended a safety seminar. They do their flight reviews and that's it. It's shocking to me, although at least a step in the right direction, that the GA.org initiative is to get people to spend 15 to 20 minutes on a safety seminar. So unfortunately, we have a lot of people that it comes down to attitude. People don't want to be told how to fly. And so until we can get past that, unfortunately, the accident rate will continue.
Yes.
Stu, let me just add to that, and Brian, that for the Cessna jet pilots, they have their Gold Star program, which is kind of like a PPP in a way, in that, they're opening themselves up to a lot of evaluation, training, and measurement. And at best, they've been able to get 15% of their membership to participate. And similarly, at the convention, when I asked for a show of hands of how many people in the room use me and my TBM, roughly speaking, it looked like 10%, maybe less. And so we have I agree with your statement of trying to get more people included, and that I think that's our big challenge. But at least with PPP, we've agreed, to use this flight operation quality assurance in me and my TBM and or FlyStow, and subscribe to, the great work that Stu has done with an SMS, including an SOP. And so it's a start.
You have to remember, Brian, that the ADS-B measurement suggests that's between 2/3 and 75% of the TBM pilots, regularly violate the POH.
Yeah, that's a problem.
But what I'd like to do is to thank William for taking the time to put this deck together, and encourage everyone that doesn't know him to get to know him. And he can be reached at William at goldbergaviation.com. And he's been a real asset for me and a lot of others. And I know Dirk has worked with him on some of the PPP stuff. I'm really proud and pleased to be a part of PPP. I'm glad that we did this, Dirk. We wondered whether we'd have any participation, not having done this before. When I talked to Dirk this afternoon, he said, if we get 20, we're lucky. And I think we ended up with 35 or 40, which is not too bad. So unless there's one last question that needs to be answered, I want to thank everyone, all the moderators, Dirk and everybody else, Stu, and Tom, and all of you that have turned PPP and TBM-OPA into what it is today.